Hi, and welcome to this simple video about running a local version of MongoDB Atlas in your Windows local environment. And this is especially useful for testing purpose, so you don't need to use a real Atlas instance in the cloud. If you can see in my repository where I've created a pull request for supporting MongoDB Atlas on kernel memory, I've created a markdown file that explains how you can run MongoDB Atlas locally on Windows in a nice Docker container. This is due to the fact that if you run the Atlas deployment setup -- type local in your Windows environment, the tool complains that first you don't have Podman installed because the Atlas uses Podman as local container engine for running a local instance of Atlas. And the problem is you got an error telling you that the local deployment are not supported on this operating system. So it seems that in Windows, you cannot use a local version of Atlas. If you look at the markdown file I've included in the pull request of kernel memory, I've explained how you can create a Docker container with Atlas. And this is thanks to the base version that it's given to you directly by MongoDB. MongoDB produce a Docker image that you can simply run with the Docker run command you find into this screenshot. But you have a problem. When you run an Atlas local instance with this instruction, each time you stop and restart the container, it will recreate a new instance of Atlas each time you start the container. So it's not usually a good solution. So this is usually the kind of container you wanna destroy as soon you finish using it. And it can be useful for various situations. But since you already have this base instance that actually has all the tool installed, you can do a smarter way of using Docker inside Docker to host Atlas, because you can create this simple 3-line Docker file in which you simply copy a start atlas.shell config and you use the start atlas to run the Atlas local setup only the first time and gracefully shut down the instance when the container is stopped. Let's see how the script is. The script starts simply using the Atlas deployments list instruction that actually lists all the installed instance of Atlas deployments. So it is simple because it returns a text description of the instances, so you can just verify if the number of line returned is less than 2. If the number of line returned are less than 2, it means that we do not have any deployment installed, because the output of this command output one line with the header and then a tabular-like information for your setup. So if you have only the header and you have less than 2 lines, there is no local deployment installed. It's very simple. It's probably there are better way to do it, but it's simple and it works. Then if the number of lines are less than 2, you can simply echo that there is no deployment found, and you can create a new local deployment giving the name local. And it's really important that you use the -- bind EP all to bind to every EP assigned to this container. And you give a username and a password. And yeah, this simply create the deployment. And in the else path, if the installation, if the deployment is already present, you just need to start using the Atlas deployments start local, because you already know that the name of the deployment is local. So everything is really, really simple. Then there is the most annoying part. If you do not include the pause Atlas function, you have a problem, because when you stop the container, the local deployment instance is not shut down gracefully. So probably the next time it is gonna start, probably it does not start. So you need to use the trap instruction, trapping the exit function and running the Atlas deployment pause the local to pause the local deployment. So the next time you're gonna restart the container, it can restart because it was shut down gracefully. And then the container, the script shell, and with the tail -f/dev/null that simply block the execution of the script. So the container it's keeping alive, it's staying alive, and you can connect to the Docker instance, to the Atlas instance. The first time you start your container, it is going to run the installation. So it will download all the MongoDB binaries for the latest version, and it will create a local instance of Atlas DB inside the container. It is running on the standard port 27017, and I usually redirect on a different port on my host operating system because usually I have standard MongoDB installation running on my host in the standard port. So I usually use a different port. After stopping and restarting sometimes this container, you can verify using the exec function that if you use the Atlas deployments list command, it lists only the local deployment. So you are not having the bug of the original container where each time you restart the database, each time you restart the container, you will have a new installation. So everything is good. The primary reason to have a local instance of Atlas is to test those functionalities that are not available on Mongo on-premise. As an example, all the functionality of searching and especially vector search. So here is, I've opened the solution of kernel memory where I've added support for MongoDB Atlas. I'm simply adding this simple connection string, and now I'm able to perform tests that are using the vector functionalities of MongoDB Atlas. All these tests are testing the search capabilities of MongoDB Atlas with vector search. So if I'm gonna execute this test, they are running against my local instance using the vector functionalities, and the test passes, verifying that my local instance running inside the Docker container is indeed a fully functional working version of MongoDB Atlas with all the function enabled, even the new search capabilities based on Lucene. And this concludes this video that show you how easy it is to create a Docker instance running your local Atlas MongoDB instance to test your software if you need to test the functionalities that are available only on Atlas and not on the on-premise version of MongoDB.